Australian truck drivers cross deserts in temperatures that reach 48 degrees Celsius. Not on a bad day, on a regular summer day in the Outback. And the trucks they drive to do it weigh 120 tons. Most people picture a truck driver's biggest challenge as staying awake on a long, straight road. In the Australian Outback, staying alive is the more immediate concern. The distances are measured in days, not hours. The nearest town can be hundreds of kilometers away. A breakdown in this environment is not an inconvenience. It is a survival situation. That reality shapes everything about how Australian road trains are built, how their drivers operate, and what happens when the system fails. Here is something most people never consider about extreme heat and a diesel engine. Internal combustion engines are already thermally inefficient. Only around 40% of the energy in diesel fuel gets converted into forward motion. The remaining 60% becomes heat. In a temperate climate, that heat is managed by the cooling system without much difficulty. In 48-degree ambient air, with direct sun beating down on every metal surface, keeping that engine from destroying itself becomes one of the primary engineering challenges of the entire vehicle. Australian road trains run heavy-duty cooling systems far beyond what a standard long-haul truck requires. Larger radiators, higher-capacity coolant systems, cooling components designed specifically for sustained operation in ambient temperatures that would push a standard engine into thermal shutdown within hours. The engineering margin that keeps a European truck comfortable in a hot summer is the same margin that pushes an Australian road train to its limits on a normal Outback run. And the engine is only part of the problem. Tires in extreme heat behave in ways that create their own category of danger. As temperature rises, the air inside a tire expands. Pressure increases. On a loaded road train hauling up to 200 tons across sealed and unsealed Outback roads, a tire blowout at highway speed is not just a mechanical problem. It is a stability event involving a vehicle the length of a small building moving at 100 kilometers per hour. Australian Outback truckers check tire pressure constantly and adjust it based on current conditions. They carry spare tires and repair equipment as standard. Because the nearest tire service is often not a phone call away. It is a day's drive away. Whatever breaks in the Outback gets fixed in the Outback, by the driver, in the heat, on the side of the road. The cargo creates a third layer of complexity that has no equivalent in cold weather trucking. Refrigerated trailers, called reefers, are built to maintain temperatures as low as -18 degrees Celsius. In ambient air below 30 degrees, they do this reliably. In ambient air above 40 degrees, the engineering margins shrink. The compressor is fighting harder. The insulation is under greater stress. And the consequence of failure is not a frozen pipe or a delayed delivery. It is a full trailer of spoiled food, medicine, or livestock feed that can no longer be used. The chief engineer of the Australian Trucking Association has noted publicly that under sustained temperatures above 40 degrees, even the best refrigerated trailers struggle to maintain -18 degrees reliably. The solution being explored is wider trailers with more insulation capacity. The obstacle is regulation. Australian road dimensions are strictly controlled, and changing them requires legislative action, not engineering decisions. So drivers manage within the constraints they have. They time their runs. They push to deliver refrigerated cargo before the heat of the day peaks. They carry the load and the responsibility simultaneously, knowing that what is behind the cab doors has a clock on it. Now here is the part that does not appear in any engineering specification. Step outside the cab in the Australian Outback at midday in summer, and the air itself feels hostile, not uncomfortable, hostile. Ultraviolet radiation at this latitude is severe enough to cause sunburn in under 10 minutes on unprotected skin. The asphalt surface can reach temperatures high enough to cause burns on contact, and the nearest shade, the nearest water, the nearest other human being may be an hour away in any direction. Drivers who need to step outside the cab to check a load restraint, inspect a tire, handle a mechanical issue, do so with specific protective equipment. UV-resistant clothing that covers the arms and legs, wide-brimmed hats, sunglasses rated for the radiation levels present in this environment, sunscreen applied before stepping out, not after, emergency water supplies carried in the cab specifically for the scenario where the driver is outside the vehicle for an extended period and cannot return immediately. This level of preparation is not cautious. It is the baseline required for the job. The tragic case of Anthony Banovich illustrates exactly what happens when preparation fails. Banovich was a driver who missed a turn and ended up stranded on an unsealed road in 40-degree heat. His truck became bogged. In a decision that heat may have already affected, he attempted to walk to safety. He was found 30 kilometers from his truck, dead from heat stroke. The distance he covered before collapsing tells you something about both his determination and how completely heat stroke can compromise judgment before the person experiencing it recognizes what is happening. Heat stroke does not feel like a medical emergency from the inside. It feels like being very tired in very hot weather. The confusion that accompanies it is indistinguishable to the person experiencing it from ordinary fatigue. That is precisely what makes it so dangerous in a remote environment where the only person who can make a decision is the person whose judgment is already being compromised. Experienced Outback drivers know this, which is why their preparation for a remote run in summer heat is as systematic as a pilot's pre-flight checklist. Water carried in quantities that account for the worst-case scenario, not the expected scenario. Satellite communication devices, because cell coverage in the Outback is not a signal bar issue, it is an infrastructure issue. Entire regions have no coverage at all. Emergency protocols established with dispatch before departure, including check-in schedules and procedures for when a driver misses a scheduled contact. And timing. The Outback does not cool down meaningfully at night the way coastal areas do, but temperatures at 4 in the morning are still meaningfully lower than temperatures at 2 in the afternoon. Experienced drivers structure their rest and driving schedules around those differences, resting during the peak heat hours and moving in the relative cool of early morning and late evening where the schedule and delivery requirements allow it. The economic reality behind all of this is worth understanding because it explains why the job continues to exist despite everything it demands. Australia's outback economy depends on road trains in a way that has no alternative. The mining sector, which accounts for around 10% of Australia's GDP, requires continuous delivery of equipment, fuel, and supplies to sites that are not accessible by any other means. A single road train can carry up to 200 tons in one trip, replacing the need for multiple smaller vehicles and cutting fuel and labor costs proportionally. The cattle industry moves up to 1,000 head of cattle in a single triple road train. Remote communities in the Outback receive food, medicine, and fuel by road train because there is no other option. Experienced Australian road train drivers earn between 100,000 and 180,000 Australian dollars annually, with specialized hauls pushing that figure higher. The salary reflects not just the driving, but the entire package of skills, judgment, and preparation that keeping a 120-ton vehicle operational in one of the most hostile environments on Earth requires. Modern road trains have added technology layers that previous generations of Outback drivers did not have. Automated braking systems, advanced navigation, driver assist technology, satellite tracking that allows fleet operators to monitor vehicle position and driver status in real time. Some newer cabs include ergonomic sleeping areas designed specifically for hot climate rest, with integrated cooling systems and temperature monitoring. But the technology sits on top of the same fundamental reality it always has: an enormous machine, a single driver, an empty road, and an environment that will turn lethal within hours if the preparation was insufficient. The Australian Outback does not adjust its conditions to what the logistics industry needs. The logistics industry adjusts its engineering, its training, and its protocols to what the Outback demands. And the drivers who cross it every summer are not doing something extraordinary by the standards of their profession. They are doing their job in conditions that most people would not survive without the preparation those drivers treat as routine.